Continue to use equations with variables on both sides, and we will focus on these travel problems. For these problems, I have a quick reminder for you. We need to recall that distance is equal to your rate of speed times your time. So we want to keep that in mind throughout all of these problems. I have these charts here to help you set up and process the information given in the problem that I will use for these first couple examples that might help you as you're processing the information as well. So pause if you need a chance to read this problem. We are going to fill in the information that we're given. We know that Molly goes 72 miles an hour and Prince Charming's train goes 90 miles an hour. We don't know Molly's time, so we're going to leave that as t. And then we can't use a different variable for Prince Charming's time, so what we need to do is we need to write his expression in terms of t. So he left an hour later than her, so that's going to be t, because t is always going to be in hours for distance equals rate times time, and that's going to be minus 1 hour. To find their total distance, we multiply the rate times the time, so they would look something like that. Since they both left from the same station and ended up at the same station, we know that the distance that they actually traveled was equal to each other. Since we know that their distances are equal to each other, we can set up our equation to show that, like this. Pause the video if you'd like time to solve it on your own. Otherwise, our answer for t is 5 hours. That is Molly's time that she takes her to get to California. It would take Prince Charming 1 hour less than that if they get there at the same time. So that means they both arrive at 6 p.m. Let's take a look at another example. Pause again if you need to read it first. We know the speeds to and from Ross Park Mall. And what we don't know how long it takes him to drive to the mall, because that's what the question is asking. So we're going to use t for the time to the mall. For our time back home from the mall, we now know that it took us 2 total hours to get to and from the mall. So if t is the number of hours it took us to get to the mall, the number of hours it takes us to get back would be 2 minus t. Multiplying our rate times our time to get our expressions for distance. And if we think about going to some location and turning around and coming back from the same location, we should know that those distances should be equal. So again, we're going to set it up to show that they're equal. And if you'd like time to try to solve this on your own, you can pause. Otherwise, when we solve it, we get t equals 1.4 hours. Or 1 hour and 24 minutes to get to the mall at a speed of 15 miles an hour. Our last example is a bit different from the first two. Pause if you want to read it to yourself. We know that this case we aren't given the speed, so we are going to use r for Liam's speed and r plus 15 for Mason's speed since he is going faster than Liam. We do know in this case that both of them drive for 3 hours. Since one of them is going faster than the other and they are stopping at the same time, these distances are not going to be equal. Instead, what we know in this problem is that their total distance apart from each other at the end of the 3 hours is 225 miles. For this reason, this equation is going to look different from the other two. We know that Mason's distance, which is 3r plus 15, plus Liam's distance equals a total distance apart of 225. When you solve that for r, we find that Liam drives 30 miles an hour and Mason drives 45 miles an hour.